In this video, we are going to find the missing coordinate to complete an ordered pair given a linear equation. In this first example, we have the linear equation y equals 6x plus 5, and we want to complete the rest of these ordered pairs. In this first one, we have the x coordinate, but we don't know the y coordinate. The way we find it is we plug in what we do know and solve for what we don't know. I'm going to replace the x value with 2 and leave the y value as a variable since I do not know what it is. Now I solve for y. Since y is already alone, I can just follow order of operations. 6 times 2 is 12, plus 5 would give me 17. So the ordered pair here is 2, 17. Same thing with these other examples. Now I know the y value, but I don't know the x value. So I replace y with -7. I leave x as a variable since I don't know what it is. I want to get x alone, so I need to subtract this 5 to move it away from the x. -7 minus 5 is going to give me -12. Now I undo this multiplication with division. A negative divided by a positive will end up negative, so x must be -2. The ordered pair would be -2, -7. Same thing with this next example, problem C, only now I'm replacing x with 0. 0 is a nice number to work with because anything times 0 is 0. So 6 times 0 is just 0, so y must be 5. The ordered pair ends up being 0, 5. Remember, your ordered pairs always go x, y. Same thing here. I don't know the x, but now I know the y. I'm replacing y with 0. I don't know x. I want to get x alone, so I have to undo this addition. I subtract 5 from both sides. And now I undo this multiplication with division. Yes, I ended up with a fraction here. It is possible to get fractions. If you do have one, just make sure that you simplify it down to lowest terms. In this case, 5/6 is in lowest terms, so the ordered pair ends up being -5/6 for my x, y was 0. Now let's try the ones on the right. I have a new linear equation. It is 4x minus 3y equals 1, and I want to complete these ordered pairs. On this first example, I have the x value, but not the y. Same thing here. So I'm going to replace first part A, replace x with 1. So 4 times 1 is 4. I need to get the y alone, so I have to get rid of this 4. It's a positive 4. I will subtract it from both sides of the equation. And now undo this multiplication with division. Y ends up being +1. The ordered pair would be 1, 1, because x was 1, and when we solved, we got y was 1 as well. Same thing here, replacing the x with a half. So a half of 4 is just 2, right? I could put this over 1, divide out the 2, I'm left with 2. 2 times 1 is just 2, or I could think of it as a half of 4 is 2. Now I need to get y alone. I subtract 2 from both sides. Make sure you don't lose this negative here. That was with the 3y. And I have 1 minus 2 ends up -1. Divide by a -3. So a negative and a negative make a +1/3. And the ordered pair here is 1/2, 1/3. Again, don't be afraid of fractions. You can get them as answers. On this last example, we have the linear equation 5x minus 2y equals 10. We're going to solve these one at a time, finding the missing coordinate. On the first one, I don't know x. Y is 0. 0 times anything is 0. I'm left with 5x equals 10. I want to get x alone. I undo the multiplication with division. X equals 2. That leaves me the ordered pair. 2 was x, 0 was y. Now I know x, I don't know y. Replacing x with -2, I need to solve for y. 5 times a -2 is -10. I have to get rid of this -10. I will add 10 to both sides. Now I have 10 plus 10 is 20. Divide by -2. Y equals a -10. That is the ordered pair. X was -2. Y was -10. And lastly, x is going to be 0. We need to find y. So replacing x with 0. 0 times anything is 0. Don't lose this negative. It's a -2y equals 10. To get y alone, I divide by -2 on both sides. Positive divided by negative ends up -5. And in my ordered pair, 0 was x originally, and we found y was -5.